Good day everyone, welcome once again to our session. So today we are going to continue our discussion on the integration procedures. So last time we talked about integration by parts using this formula, integral of u dv equal to u v minus v du. Okay, so this time we're going to solve number 5 of our sample problems. So number 5, we are given the integral of secant cube x dx. Okay, so how are we going to solve this problem? So to solve this problem, again, we are going to apply our integration by parts, but before we can do that, we have to rewrite our given. We have to break this into two parts. Okay, so we have secant cube x dx. This can be written as integral of this is equal to integral of secant x times secant squared x dx. So we had broken this into two parts, secant, or two factors, secant x and secant squared x. This is equal to secant cube x dx. Alright, so from here we can choose. We can choose what is our u and what is our dv, because we have to follow this form, integral u dv equal to u v minus v du. So if it is in this form, if this is our u, then this is our dv, then we can use this formula. Integral of u dv equal to u times v minus the integral of v du. Okay, so if we let our u be equal to secant x, then the rest will be our dv. If we let this as our u, then the rest will be our dv. So if that is our u equal to secant x, then our dv equal to secant squared x dx. Alright, so that is our dv. Okay, so from here, if we are going to take the derivative from our u, if we take the derivative of u with respect to x, so derivative of u with respect to x, so from our differential calculus, so the formula is, if we have derivative of secant u, that is equal to secant u times tangent u du. Still remember from our formula from differential calculus, if you're given the derivative of secant u with respect to x, so this is equal to secant u tangent u du. Okay, so let me erase that. If you have derivative of secant u with respect to x equal to secant u times tangent u. Okay, so that is our derivative of secant u with respect to x equal to secant u times tangent u. Okay, so from here from our derivative of u with respect to x. So this is equal to secant x tangent x, following this formula. Alright, so solving for du, our du therefore is equal to just cross multiply dx, or multiply both sides by dx. So we have secant x times tangent x dx. Alright, so that is our du. Then how about our dv? So our dv is equal to secant squared x dx. Now to solve for our v, so let me erase this. So to solve for our v, so we have to integrate, no? We have to integrate our dv, or both sides of this equation dv. Okay, let me rewrite it in class. So our dv is secant squared x dx. Okay, then integrating both sides of this equation. So integrating the left side, so you do the same on the right side. So integral of dv is equal to v. Now, as mentioned earlier in the previous examples, we need to check if we can use the formula, because there's a formula of our integral calculus. The integral of secant u du is equal to tangent u. No? If you have say integral of secant squared u du, so this is equal to tangent u. Okay, but of course you need to check, no, if you have a perfect du. But since our u here, we can consider it as u is equal to x, so derivative of x, or the differential of x, is equal to dx. So this seems to be a perfect du, or this is surely a perfect du. So therefore we can use this formula. So when you integrate dv, which is equal to v, when you integrate secant squared x dx, so this is equal to tangent x. Alright? So summarizing our result. So we have our so I'll summarize it here. So our u is equal to secant x, then our du equal to secant x tangent x dx, then our dv is equal to secant squared x dx, then our v is equal to tangent x. Alright, and again, let's draw a vertical line and also the horizontal line. Then do this arrow to remind us that we need to multiply u and v for our first term of our result of our integral of u dv. Alright, so rewriting here, I will rewrite the formula here. We have the integral of u dv equal to u times v minus integral of v du. Alright, then rewriting our given. So our given is the integral of secant cube x dx, which is equal to, we break this into two parts. Just to find this are u and dv, but we don't have to rewrite that. Now you don't have to rewrite that. We just go directly with this form. So using the formula, you have, or just to make it clear, so I will rewrite it here. This is equal to, so we break this into two parts. So we have integral of secant x times secant squared x dx. Alright, so this is equal to this one. We have u, right? We have our u dv. So this is our u, and this is our dv, right? So integral of u dv. So using the formula u times v, right? So u times v. So writing the value of our u and our v. So our u is equal to, this is our u. So this is our u, which is equal to secant x. So therefore, this is equal to secant x as our u, then times v. So our v is equal to tangent x. So therefore, secant x times tangent x. So this is our u, this is our v. Then minus the integral of v. So our v is tangent x. Okay, so our v is equal to tangent x. So tangent x times du, right? So we have v du. But what is our du? Our du is this one, secant x tangent x dx. So our du is secant x tangent x dx. Alright, so that is now our resulting integral for the second part. So equal to, so rewriting, we have secant x tangent x minus, we have tangent and tangent. So this will be integral of tangent squared x, because we have two tangent here. Tangent x times tangent x, that is tangent squared x, times secant x times dx. Okay, so after that, we have to make use of the trigonometric identities. So what is this trigonometric identities? We have an identity that, okay, sorry class, I have to put it here. Alright, so our trigonometric identities, we have, so I'll just write it like this class, trigo, meaning trigonometric identities. Identities. Okay, so trigonometric identities, we have tangent squared, tangent squared u is equal to secant squared u minus 1. So we have to make use of that identity class to replace our tangent squared x here. You were using this trigonometric identity. This one, tangent squared u equal to secant squared u minus 1. So substitute it here, replace u with x, and writing this, we have secant x times tangent x minus integral of, instead of tangent squared x, we write secant squared x minus 1. Alright, then multiplied by this, which is secant x dx. Okay, then distributing secant x dx to its term, you have two terms here, and together with the integral sign. So distribute and multiply, that is our first term, and also here. So we have secant x tangent x minus integral of, we have secant squared x multiplied by secant x dx. So this will be secant cube x dx. Okay, then this one minus, this is minus, so minus integral of 1 times secant x dx, so that is equal to secant x dx. If you have noticed, class, we have secant x cubed dx, which is exactly the same as on our left side, the given. Okay, so rewriting the one that is on the left side. So we have secant cube x dx. All right, and then we have here secant secant integral of secant, this one. If you transpose this to other side, or if you add both sides by integral of secant cube x dx, so what will happen if you add something like this? So this will be 0, but you're adding the other side with the same expression. In other words, when you transpose that one, no? When you transpose to other side, so we have on the left side, sa left side, what will happen to the left side? So we have integral of this one. I will rewrite this secant cube x dx. Okay, so this is negative, no? This is negative. When you transpose this to other side, that becomes positive. So that is positive integral of secant cube x dx. Then equal to, so you just copy this. We have secant, or just to be consistent with the position of our equal sign. So I'll put, instead of putting it here, class, I will put it here. Okay, I just okay, I think it's not readable. Okay, this one. Okay, so I will put the equal sign here. So rewriting this, so we have secant x times tangent x, then minus, so what is left here, this is minus integral of secant x dx. Okay, so we have secant x cube, secant cube x dx plus secant cube x dx. So meaning one part of it added with another part. So we can say that there are two integral of secant cube x dx. All right, so you just write only one of them, then just multiplied by 2. So they are just the same. So you see our expression now reduces. It reduces from this very long one, and then it reduces like this. So to get back to the original given, okay, original given trigonometric, integral that contains trigonometric function. So we have to divide this both sides by 2 to eliminate these 2 here. Okay, so when we divide both sides by 2, so divide. So this is a very, so I have to make use thinner. So dividing, divide both sides by 2. So what will happen when we divide both sides by 2? So this will be equal to 1. The coefficient here becomes 1. So this becomes integral of secant cube x dx equal to, so we have secant x tangent x, divide this by 2, okay, then minus integral of secant x dx. So divide this by, or you can just divide all of them by 2, no? All the terms together on the right side. So something like this, divide by 2, so that you can put the 2 outside, no? I mean on the leftmost. So okay, I'll continue it here on the other. Okay, so after dividing this by 2, so this is the result. So I will rewrite it, class. So we have now the integral of secant cube x dx equal to, so this can be written as 1/2, right? 1/2 times secant x tangent x, then minus the integral of secant x dx. Okay, so the 1/2 here is common to its term. Or you can distribute 1/2 so that we will have 1/2 secant x tangent x, then minus 1/2 times the integral of secant x dx. So you can also rewrite that way. Okay, then after that we have to figure out on how to integrate this, because once we have integrated this, then we finally get the answer for this one. But how? So we have to make use of those formula, class, in the differential calculus. So the technique here, if you look at the formula of the differential calculus and integral calculus, you can figure out what algebraic manipulation that you can do, no? to come up with something that can help us integrate or solve the integral of this given function. So I will not elaborate that more, but I'll just show you how to do it. So from here, if we are going to multiply both numerator and the denominator by this ratio, which is secant, if you multiply this by secant x plus tangent x, so you're changing the expression now. So to balance it, to retain 8, to make it the same as this one, so you also divide this by this one. In other words, we're just like multiplying by 1, because the numerator and denominator, they're just the same, so that is equal to 1. So we're not changing this integral here. Okay, so the purpose is that we can manipulate this in such a way that when we compare it with the formulas, we can the differential calculus formulas and also the integral calculus formulas, we can make use of them. Okay, so multiply this by this one. Okay, and then simplifying, we have 1/2 secant x tangent x minus 1/2. So this becomes integral of, you have secant, because you have to multiply this one. Okay, and also this. So what happens? So this will be secant squared x, because you have secant and secant, so secant squared x, then plus we have secant secant x times tangent x. Alright? And then the whole thing, so you just put this inside the parenthesis. Okay? And then the whole thing is multiplied by dx. Alright? And the denominator, so we have the same denominator, which is secant x plus tangent x. Alright, so that is the resulting integral. Now, if we let this denominator, if we let the denominator be equal to our u, so secant x plus tangent x as our u, then when you take the derivative of this with respect to x, so derivative of u with respect to x equal to, what is the derivative of secant u or secant x? So the derivative of secant u, we have a formula that the derivative of secant u is equal to secant u tangent u. Right? So derivative of this part, this first term, is equal to secant x times tangent x, then plus the derivative of tangent u. So from our differential calculus, the derivative of tangent u is equal to secant squared u. So therefore this is equal to this is equal to secant squared, no? This is secant because derivative tangent u is equal to secant squared u. So this is secant squared x. Okay, so if you look at the numerator, so the numerator is, we have the term secant squared x. We also have secant squared x. We have secant x tangent x. So we have secant x tangent x. It's just a matter of the position of these terms here. We can rearrange, no? We can rearrange. So our du could be written as our du over dx. This can be written as secant squared x plus secant x times tangent x, so that we can see it exactly same as the numerator. Okay, so we have this form. We have this form du, no, integral of du over u. So if you can still remember from our discussion before, no, we have our a rule that if you have the integral of, sorry, so if you have the integral of 1 over u du, which is equal to integral of du over u, so this is equal to ln u plus c. Okay, so we have to make use of that formula, class. So therefore, writing it, so we have 1/2 secant x times tangent x, then minus 1/2. So this is in the form of du over u, so which is equal to ln, because this is in the form of du over u, no? du over u, which is equal to ln u plus c. So we can now use ln u, which is our u is this one. This is our u. So ln of u, which is secant x plus tangent x, then plus c. So that is our final answer. Okay, so let us check. We have 1/2 secant x tangent x okay, sorry class, we have missed the sign here. So because we have here, sorry, I missed the sign. I think we have made wrong of the sign. So I'll get back here. So we have minus, you have minus, you have minus, minus. So this should be plus. Okay, this should be plus. So this should be plus because this is minus of the whole thing, right? This is the whole thing. This is coming from here. So this is minus, so this becomes minus. Then minus, minus, right? Minus, minus. So that becomes plus. Sorry class, I missed the sign. So that should be plus. Okay? So it means, so we have plus here. This also plus. This also plus. This also plus. Sorry for that. So this is our final answer. Okay? So I hope the solution class is clear with you. And I hope you understand the process and you're able to follow it. Okay, so thank you very much and hope to see you again in our next video. Okay, bye for now.